recording. I forgot to start it. We just said that the slope is the number with the x. Make sure you remember too, I didn't say this for you guys, so this is for you guys too, not just the recording. That means we are taking 1/2. A lot of room, and it's gonna, oh, here, I'll write it over here. 1/2 times x. So that's what that means. Like, it's not just 1/2 next to x. It means we're multiplying 1/2 times x. We also said that the sign in front of a number is glued to it. That's why -3 is circled. That's also why the y-intercept. So the y-intercept is the b. Oh. So the y-intercept is the b value. So that's the y-intercept. That's the slope. That's why we put slope there in 1/2. But yeah, the number or the sign in front of a number we said is glued to it. Oh, we said the reason this has a box around it. The number multiplied by the x or with the x is only the slope if y is all by itself, because that's slope intercept formed. So that is also slope intercept formed. Y is by itself. Did I miss anything? You know what that's it? Yeah, good, right? And then we were just trying to pull out the slope and the y-intercept for this particular. Oh, so here's what I was talking about. So the y-intercept visually, this is going to graph a line. Right? I think hopefully we remember that's kind of what we did a lot of times with an equation. Even before I graph the line, just by knowing this is the y-intercept over here, I know that's going to be a point on the line. Because that's where my line is going to intersect the y-axis. That's what the y-intercept is. My line, wherever it goes, I know it's got to go through that point. Maybe it's kind of straight up and down. Maybe it's flatter. Maybe it goes down left, right. Maybe it goes up left, right. That part I'll figure out in a minute. But I know it's going to hit that point because that tells me that right there, the y-intercept, the negative. All right. So we're going to do more with that in the actual new lesson today, but let's get to the reflect over the y-axis. So a lot of you probably can visualize how the point would move without doing what I'm about to do. If you can, that's great. It does get trickier, though, when you do rotation. And what I'm about to show you will still work for rotation. Just make sure you keep it in mind and don't forget about it just because you can visualize reflections a little bit easier, because they are easier to visualize. If it is a rule, so again, there is a one specific rule that is always true for whenever I reflect over the y-axis. If it is always true, it doesn't matter where I start. It doesn't matter what point I pick. Pick any point on it. I would always do this and start with a positive and a positive. It just, maybe I don't ever have to deal with a negative up start. Maybe I'll still have to, but maybe I won't have to. Because I know my first two are positive, that's for sure. So I always start kind of with, and I like to have two different numbers, because if you don't and they flip places, you're not going to be able to tell if your number, like if I start with 1 and 1 and they flip places, well, I still have 1 and 1. So I can't tell that they flip places. So make sure you have two different numbers, and I like to start with two positive numbers. So I start with 2, 1. I mean, if you want to, just always start with 2, 1. Just use the same one. I'm not going to force you to do that for whatever reason you want to do something else. That's fine. Now I just do the reflection over the y-axis. Like, hopefully you know how to do that. I forget why I went all this way and this way. What is the main thing I got to know how to do when I do a reflection? First thing and the main thing. After that, it's pretty simple. Or just tell me how to reflect it over the y-axis. We have to do it. Why? Like the question why. Somebody why did you? Not wrong, but why are we doing this?
Because of the x value?
No, that wouldn't be it. I don't think. I mean, I guess there's a way that could still be correct, but I don't want to say that out loud. What are we doing? We're reflecting it over. So we need to darken in the line of reflection. So again, if you don't know that, I've harped on that a lot when we're doing this. If I say that is the number one thing you know, you better be writing it down and memorizing it, setting reminders, whatever you gotta do. That's the thing you shouldn't have to think about. So when I say get the most basic stuff down for each lesson where you don't even have to think about it, that's it. Some of you still haven't written it down. You didn't know it. Write it down. Make it a point to remember it. You're not going to do well in this class if you don't do that. And if you haven't heard, there's no midterms. Why do you think, oh, great, no midterm? Well, the problem is that means this quarter is more important. Because now there's not a third piece that could help some of you out. Like I told you, that saved some kids last year. I'm going to save anybody this year. You got one option left now, and that's to do well this quarter. And even frankly, if you did well, some of you, again, if you truly want to like do better, you can't do better now by doing well on the second quarter and the midterm. You only have the second quarter. Now, if you were happy with your grade and you're fine, can't slack off, but you have a little bit more cushion if there's no midterm. But so there's upside and downside of not having midterms. Make sure you understand it. So I need to say, well, I'm reflecting over that. That, in this case, that's my line of reflection. Well, then I just darken in. You need to know where the y-axis is. It's the up and down number line, the up and down axis. So I darken that in. That's your first step. You gotta know that your first step is to darken in whatever the line of reflection is. And they'll always tell you what the line of reflection is. They'll say reflect over or across, and then they'll tell you what it is. It might be the y-axis, the x-axis we've done, x equals a number, y equals some number, y equals x, y equals negative x. It could be any of those, but regardless, your step's the same. You need to create that line. And again, that's algebra. That is not geometry. That is knowing how to graph a line. Not geometry at all. Now I do what you were saying, Smaria. Now, once I have the line, I move however many spaces toward line I count. So I move 1 hop, 2 hops, and now I'm at the line. Well, I need to put a reflection on the other side. So I go the same number of hops, 1 hop, 2 hops. So even without a perfect graph, that is graph paper, I can still, hopefully you can still see, well, this point would be -2. Oh yeah, -2, and then I'm still at +1. I just went straight over. The hops are a little confusing, but I'm looking at the point relative to this y-axis number 1. So I write that down. And again, I'm pretty sure you'll have graph paper, but I'm still, just in case, I want you being able to create it. Now I just look at the actual numbers and see what happened. Nathan, you're up. Tell me what happened to the x value. But what do I say? Numbers don't become negative. Because what if I would have started over here and reflected that way? Didn't become negative. But what do I say? Instead of saying it becomes negative, what is it? Flips. The sign flips. If you see a sign change, we don't ever say it becomes negative. Because if we would have gone the other direction, it wouldn't have become negative, it would have become positive. The sign flips. So the way we show that, we said, when we're doing this rule stuff, is we put a negative in front of that value. If it flipped with the actual numbers, then we put a negative in front of the variable x. Nathaniel, you're up. What happened to the y value? If you need help, I'll just kind of show you where they are. That was the original. That's my final one. What happened? Nothing at all happened, right? Then we just put y. If nothing changes, it's just y. So now I just look for that ruler. Well, oh, I meant to do a show of hands. I forgot that in this class too. I forgot it last time. So hopefully I'll remember. We just have 7. Yeah. Huh. So that will work for all rotations, all reflections. Translations, it works, but I don't think you need it. Translations are much simpler in my opinion. So In the past though, because I thought they were simpler, I barely covered them and this kid struggled. So this year I'll still cover it in more depth, but I still don't think you'll need that. I think you'll be able to figure out terminology. Yeah, I mean, that's it. I'm trying to sprinkle that in because when we get to it, we're going to try to focus more on the tougher stuff, which is the rule stuff, especially with rotations. But that will work. Any questions? All right, so turn the page. If you don't have your books, which like a lot of you don't, go ahead and get your books. If it's over there, get it. If it's in your backpack, get it out. Feel like I'm missing something, but I don't know what it is. Maybe it's just because I talked to them about grades for every lifetime. I'll tell you what I do sometimes, and I will be offering this right now. I'll tell you what took me so long last guy, but let's go for more. Be careful what you say to your parents about this class and how hard this class is. I know that's what you're telling me. They're telling me. They're telling me you're saying it's too hard, which they believe you when you say that. And I'm not saying it's an easy class, but it's not hard. I got kids that are not strong at all in math. They're making C's in this class. But they're in here all the time, tutoring and taking retakes. And they take a retake one quiz 3 times. So that doesn't mean it's hard. That means you have to work hard. Hard means, hey, that I'm just not able to get it. Mentally, I'm not that strong. That's not true of any of you. Not to pass or get. I get getting A's and B's in the class is hard no matter what. How hard you work, for some people it's not. But don't ever think that you can't pass this class, and don't tell your parents that it's too hard to pass. Because here's what I offered one year. I haven't done it recently, but wasn't that long. I had a kid that, and this is in life. Be careful what you say because it can bite you back. But I'm just using it. They were telling their parents how hard it was. Meanwhile, they were a pretty smart kid, and they sat here and did nothing on it. But their parents believed them because they probably weren't good at math either. So they're like, yeah, no, I get geometry was hard for me too. That's what I've heard parents say. Math's really hard for me too. I'm not good at math either. So they believe what you tell them. So I said, you know what, ma'am, sir, whoever it was, I really believe in your son or your daughter. I don't really. I really believe in them. See, I believe in you. I believe in your daughter. So I normally charge $40 an hour to tutor. I will tutor your son, daughter for free, which I do. But one-on-one, I do them one-on-one tutoring for free. And if transportation is an issue, because you can't get here, at like 3 or 3:30, I will stay until you get off of work. And we will tutor for 3.5 hours or 4 hours, whatever it takes for you to Sunday school today. You don't think there's a parent out there that won't take free tutoring when it still fits into their work schedule? So now you just got stuck in my class tutoring for 4 hours when you could have done the work on your own, maybe. Yeah, you would have to work a little bit, but it's a lot better than the 4 hours you're going to get stuck with. I will start off from that to teacher or to parents. If you are not working, start working. Drives me crazy that some of you tell your parents that and that they buy it. Oh, and then also the other thing, because I've been calling parents and I'm here to say, well, they tell me they don't have homework. No, ma'am, no, sir, that is absolutely not true. I don't collect the homework. You have homework. I stick backs. I never thought I should take a picture of that. Yeah, look at this. They've had homework. Yet you're going home and not doing a single thing. So just know those calls are happening. I've already seen changes from some kids and had some conversations just like what I just did, where the parent was being told the exact opposite of what is true. Drives me crazy. Creates more work for me, but if that's the way I got to get you to work, then that's the way I'm going to get you to work. All right, so page 191. We're doing a lot of stuff with slope, equations of lines. What we wind up doing today, we don't even get to the toughest stuff. I told you this lesson gets really complex. We actually didn't even get to it today, even in first period where we covered more ground in third period. So what we do today is kind of like the easiest level, then the medium level, and then the hard level we'll do We may not even do that tomorrow. Oh, no, crap. We got to all the other. Bring your laptops Friday. We're doing the district test. I've already told you once, but I meant to remind them. We're gonna do the district test in here. Just take care of that. Since we're actually not too bad on the pacing guide since they pushed that back. But yeah, make sure you have your laptops. I have a few. If you absolutely don't have a laptop. All right, but yeah, I only have 4. So if a bunch of people forget it, then and that I can't have you work together. So I need people that have their laptops. Oh God, I got to send an email about that for the just first period because I see third period tomorrow. All right. So what does slope? Where did I end on? Gilberto, what does slope tell us? Bunch of answers. Almost, if you know anything at all that stuff, almost no way to be wrong. What would it tell you? Tell me how you would describe what slope is. That exact one I want. It's fantastic. So if you just, I mean, does anybody know what like mountains, like skiing a mountain slope? Like you heard maybe a slope of the mountain, like it just tells you how steep something is. Like a steep mountain would have a really vertical slope, really straight up and down slope. Wouldn't really probably be a mountain, but a flatter mountain would have a very gradual slope. Like if you think about a ramp, like for people that have wheelchairs, they always have a very gradual slope. Because if it was really steep, it'd be hard to push a wheelchair up. Actually, there's a legally, when you create a ramp for a wheelchair, there's a legal limit to how high the angle. I learned that through our book. Our book had a math problem and it tells us that in the book. We'll get to it eventually. So slope is a measure of what is the tilt of the line, what's the angle of it, how up and down is it? Also, what direction is it sloping? Like, does it slope down from left to right or up from left to right? It's a measure of that direction as well. If you just have that concept, those 2 concepts down, like backwards and forward, you do not have to memorize it. I mean, think about it. Just have them down. Make reminders, like I said, a calendar app or a reminder app. It will save you from missing problems because of math, which you're going to make math mistakes. I made math mistakes earlier when I was doing it. I'm the math teacher. It's just easy. If you get going too fast, it's easy to skip over something, do something wrong. But I corrected myself. I went, wait a minute, that can't be right. Because I understand those 2 concepts I just told you. So here are the concepts. I'm going to write them down for you. We'll take quick notes. If I have a line, do this. Let me go down a little bit. Do it lower. If I have a line, I'll do it over here. That goes up from left to right. So again, I always describe it the same way. If I were Ant-Man, little tiny Ant-Man standing on the left side of that line, and if I walk to the right, if I walk that line, if I'm walking uphill, and if I'm here, I'm still walking uphill, just really uphill. My board is really off, so not much I can do. I'll have to try to correct it again. That is a positive slope. Any line that I would be walking uphill, left to right, you have to start on the left, always. That's a positive slope. Both of those, positive slope. Oh. I'm going to try to fix that. Positive slope, no exception. Going up from left to right, positive slope. If I am little Ant-Man guy, it's weird because my board works fine in the middle, but just it's on the far right. If I'm walking down from left to right, again, doesn't matter. Would be a much steeper line. If I'm walking down when I go from left to right, that is a negative slope. No exceptions. Anytime I say no exceptions, that's when you got to remember. If I'm now, because you're going to calculate slope out today, you're going to have to plug numbers in, make sure you put them in the right place, make sure you do the math right. formula right, all that stuff. If you make a mistake, the odds of you making a mistake that you don't catch are pretty slim, especially after I add the next piece. But make sure that's the first part you do. So here's the next part. The number, because the slope is a sign and a number. Like in the last one, it was 1/2. One time it was -1 when we did it. I've used -3 before. So the number part has to do with how straight up and down versus how flat the line might be. So the bigger the number part, the more straight up and down it is. And here's your guideline to know what, I don't know, is that straight up and down or is that flat? Anybody have an idea what a slope of 1 is? When we graph slope, how did we graph using the slope? What's the formula for slope? Not the y2 subtract y1 back. That's the whole equation. That's over here. Rise over run. How far right or left do we go, and then how far up or down? Well, a slope of 1 means we go over 1 up 1. So it's always going to go over 1 up 1, which means it looks like that. It goes right through the middle of like a 90-degree angle. It's halfway, between a 90-degree angle. It's 45 degrees. One of the numbers. So if that's 1, anytime we have a slope that's flatter than that, it's a fraction. It's less than 1. So this one would be a fraction. It'd be negative. That one would be negative, and it would be a fraction, less than 1. This is really steep. Anytime it's a lot steeper than that 45-degree angle, the number part would be big. So it might be -3. So this one might be -1/3. That one might be -3. So I'm just guessing. We're going to do some. You'll see what they look like. Up here, for the blue ones, they're going to be positive, but that really steep one, that might be +4 up there. This one might be +1/2. Again, just kind of guess. So again, you can use those two things. That's what a 1 looks like. And again, if it was going down like this, that would be -1. So when we graph y = x, if you remember that, that's a slope of 1. Because again, 1 would be in front of the x. That's the value in front of the x. So if we graph y = -x, that's a slope of -1. And that's what they would look like. The blue and the red would be what they would look like. If you just memorize that, even if you don't fully understand, just make sure you don't even have to think about looking at a line and what it might be. When you do math wrong, you'll catch it every time. And you will. I'm just telling you, it's going to happen. It's just, you get going fast. There's quite a few steps in it sometimes. All right, so here's the lesson part. I mean, that's review. Most of this is algebra, by the way. There's almost no geometry in this. Not what we do today. About the only geometry. Actually, you even did this in algebra, I think. So what would the slope of 2 parallel lines, like, what would be true about that? What would you say about the slope of 2 parallel? I don't know about that. Catherine. So what would be, so if they're parallel, they'd be at the same angle, right? Like that parallel means they're never going to touch, so they have to be at the exact same angle. So what would be true about their slope? Be the same. So that's the first thing you need to know. And it's in your book up top, like right at the top of this screen. You can look at the book too. Parallel lines have the same. Doesn't matter if they're both negative, both positive. If they are parallel, whatever one slope for one is, then the slope is the same for the other. The y-intercept will be different, typically, but the slope will be the same. Otherwise, if they had a different angle or a different tilt, perfect way to describe it, eventually they're going to run into each other. They'd have to be at the same angle to never hit each other. So they have the same slope. So the second part then, really the main one we have to remember, for perpendicular lines. Let me do this last part. For perpendicular lines, this is how they look, and then I'll explain what they're saying there. If we want to create, which we will in this lesson, let's say we have a line and we want to create a perpendicular line. Well, then we need the slope to change. They can't have the same slope if we want them to be perpendicular. And we have to change it in the exact correct way. I take the original slope, so let's say it was just a number, not a fraction. If my original slope is -3, I need to take that number and make it a fraction. Remember though, this is -3. The sign of this is negative. That's still one number. Don't treat the 1 and the 3 as two different numbers. That is one number, just it's a fraction. So it's a -3. I need to actually flip the fraction part, flip the top and the bottom, and I flip the sign of the overall number. So don't flip the signs of each of these and make that, oh, then that needs to be -1 and +3. Because that would still be a negative number on the right. -1 over +3 would be negative, just like -3 over 1 is negative. I need to flip the sign of the overall number. Good news is, even if you mess that up, this last part will catch that. When you, and that's what it's saying right here. When you multiply two slopes together, so make sure you highlight what I just put above or write it down next to it. If you multiply two slopes together that are perpendicular lines or perpendicular slopes, you'll always, again, no exceptions, get -1. So if you do happen to make a mistake when you create the perpendicular slope, just make sure you multiply the two slopes together and just kind of check your work. Check to make sure you do it. Because there's no exception to that. Two perpendicular slopes. Oh, sorry, one exception. What is the slope of a flat line? Horizontal. 0, right? I can't multiply 0 times something and get -1, but I do have perpendicular lines with a horizontal line. What's perpendicular to a horizontal line? Look at the x-axis. That's a horizontal line. So what's perpendicular to the x-axis? Vertical line. So again, you just need to memorize that part. And it says somewhere in the top part, just memorize it, and you should know this already. A horizontal line, I mean, that's the grid lines on the graph. All of the horizontal lines are perpendicular to all of the vertical lines. So, but just don't forget about it. But other than that one exception, if you multiply two slopes together that are perpendicular slopes, you will always get -1. But, so again, that's the easy stuff. Make sure you memorize that stuff so you don't even have to think about it. So that when you have the more difficult stuff, you have time to think about that stuff. All right, so here's what we're going to do. In the first two examples, they're not that bad. This is the easy part I told you for this lesson. They just give you either two lines, that's example 2, or they give you the coordinates that are on two lines, which is example 1, and they just ask you, are those two lines parallel, perpendicular, or neither? So what would we need to do? Kind of finished off of that side. I've already asked you, Jason, you guys see this part, right? Skip down, Becky, we're getting to the part you got to at least watch. So what would I need to do in order to determine if my two lines were parallel, perpendicular, or neither? What do I need to know about them? I need the slope, because I know if they have the same slope, they're parallel. If they have slopes that when I multiply them, I get -1, they're perpendicular. And if neither of those two things happens, then they're going to intersect somehow, just not perpendicular, which means the answer is neither, the third option. So here's how you do it. Look at your reference sheet. If you don't have one, find one, get a calculator also, because you'll need that now. Zoom as far in as I can. I don't think anybody was still writing, but I'm recording, remember, so if you were still writing, you can go back and fill in. So they give you in the first example. Now again, this is the solution. Don't look at that. Don't look at that. They're doing it for you. You wouldn't have that. You need to know that's what you do. So that's what I mean. We just need to understand that we need the slopes of the two lines. So the slope formula is on your record sheet. You don't have to memorize that. Just memorize it. It's on the side with the two triangles, and it's in the where all the boxes are. I'm pretty sure it's this one on the far right. It's that y2 subtract y1 divided by x2 subtract x1. Kind of like when we did the distance formula. We labeled x1, y1, x2, y2. So I'm going to take, actually, go ahead and put those points on the graph. All right, don't put the points. I'm going to help you because look at the graph. What's weird about this graph? The actual graph, it's like paper. Well, so the 0, 0 point, the origin's a little off center. It's not right in the middle. What else? There's a bigger thing that you wouldn't maybe even catch if I didn't make you look at it.
It's by chance.
Well, that's what he was saying.
I think I know something. It goes by 2.
That's perfect. This graph does not go by one. Look at it. If this is 4, that's got to be 2. Again, if that's -4, that's got to be -2. So just be careful. Sometimes, even on the EOC, I think, and definitely on the district stuff, they will do that. Because they just take questions from a test bank and it's probably from the book or something, and that's what the book does sometimes. That allows them to fit points that are higher points, like 10 or 11 or -9. Like it allows them to put higher numbers on it. I don't know why they do it, because it's still the same concept. So when I put these points on there, I just need to make sure I remember that. So this is one line. That's line AB. I'm going to come back and do line CD in red. So if you want to try to do it now that I've showed you that, you can. I just wanted to show you that. So let's see. A would be 3, 6, which again is going to fall in between grid lines. So 3 is there, 2, 4, 6. So that's about where that point would be. So it's kind of in between grid lines. -9 would also, any odd numbers are in between. So -9 would be there. And then 2 here. God, my board is so off. I gotta try and fix that. Oh, actually, here, I can do this. Ooh. Oh, wait, no. Oh, there you go. There we go. Actually, now that I can do that, let's just get rid of that now. Hold on. I'm gonna make it a really small point. Oh, that's right, I forgot. Forgot I had an eye on you. So negative, done with testing. That would be, oh, no, he's right here. Have you already tested? Yeah. So you might be getting called out. We're on page 191. So grab your book, grab a calculator and your reference sheet. So now that I have the 2 points on there, I'm just gonna, if you're really picky about this, I don't have tons of rulers that I hand out, but I'll give you an index card. These work fine for just making a straighter line if you want to use index cards. If you have your own ruler or something, I'm just going to draw it in. It does not have to be perfect because ultimately I have to do the math anyway, just to make sure. So something like that. Boy, that got really crooked at the end. Now it's less crooked. So there's my first line. I just put the 2 points on the graph and then I connect. So I'm going to do this one in red. Oh, and I went through it because my board is off. So +5 is there, and then 4, and then +2 and 3. I'm going to move those. Oh, I do want to show you this. I wish I could zoom in more. I don't. Yeah, that's as far as I can zoom in on this. Oh, that's not good. Shoot, I really can't get in the middle at all on that. All right, so here's what you can do to make a straighter line. When the points are really close together, There we go. So when the points are really close together, it's hard to make a straight line sometimes. You get off by just a little bit, even with a straight edge. It's going to be off a lot toward the end. You can keep repeating this pattern over and over going to the left and make more points. So again, it's kind of tricky. I'm going 1.5 that way, right? So 1.5 squares. Now I'm not talking about the numbers. I'm just talking about the squares. The squares go by 2, so it's a little different. So 1.5 squares, down a half. So again, 1.5 going left, down a half would be about, oh boy, that's. Oh, tell you what, I'm going to do it with I'll just do it with the mouse. That's better. So here, yeah, let me do this. So I'm just making more, and you'll see they line up. So if I go over 1.5 left, down a half, that would be about right there. Oh, it's too big. I'll fix that one in a minute. I don't really need to. So again, over 1.5, so that would be there, and then down a half would be there. And you just keep doing that over and over again. And then last. So you'll notice that makes it a lot easier to line them up with a straight edge and make the line. Third time I've done this time. I gotta fix that. That is way driving me crazy. I don't see you guys tomorrow, but want to see. I'm dressing up as Mr. Cool. All right, folks. Makeup, earring, everything. All right. So now hopefully this is straight. Oh. So something like that. Again, my lines weren't perfectly straight with the blue line. So visually, it looks like they could be parallel, right? Definitely not perpendicular, so I can eliminate that. So I just have to figure out if they're parallel or if they're neither, meaning that they're going to intersect eventually. So I need to find the slopes. So here's how you do that. I would not take shortcuts, especially at the beginning. Label your points. So A is 3, 6. B, oh man. Which line did I do? I did this in red. I should have done it in blue, but I'll fix it. So B, fixed it. Well, it didn't fix it apparently. Let me do it again. I just don't get why this board does this. It's the weirdest thing. Something's in front of the center or what? Very annoying. Does anybody know why a lot of teachers are wearing pink today?
It's breast cancer month.
So negative. God, still not. Oh, here, let's do this thing. Now it's not even working in the middle. Oh, you know what? If I write slow, nope, that didn't work. I don't know what's going on. This is really annoying. All right, so there's my point. I can't even really use the mouse to try to make this easier. I'm gonna try to write slow. Let's see what that works. So when you do the slope, it's just like when we did the distance. Label one, and it doesn't matter which one is your x1, y1, which one's your x2, y2. Like that's worse than it was before. Oh, now it's like. And as soon as I like tell them it's broken and come fix it, it'll work fine when they come. There's no sense. I may have to go to whiteboard after. Well, I can't. All right, that's better. X1, Y1, X2, Y2. Perfect. There we go. All right. So once you've labeled them, You left one or you were, well, I don't know if it, yeah, I think you were sitting there, but I didn't remember which class. So now I write the formula again. You don't have to memorize it. Do not take shortcuts and try to do this part like by just looking at the reference sheet and then back down to your paper. That's when kids mess up and they don't always catch it. That's also why I went through that whole beginning thing, so hopefully you do catch it. Tommy, Jason, wake up. There we go. So I'm gonna say, what is my y2? It's 2. I'm writing it right next to the formula. I mean, literally, if you want, write it right on top. I just don't want to write over the tops of letters. Subtract is part of the formula. So always write the subtraction sign. Then, if the number is negative, you have to include the negative sign with the number. Remember, it's glued to the number. In this case, my y1 is positive, so it doesn't happen. Now, x2, -9. And then divided by, subtract. Again, part of the formula. X1 is 3. So when I do the math, -4 divided by -12. If you do that in a calculator, it probably automatically did it for you and gave you, well, actually, no, you would have probably done those separately, would be my guess. Regardless of how you get there, positive 1/3. You do need to simplify it. Make sure you simplify it down to the smallest fraction you can get. Your calculator actually does that for you. I don't remember how, but I'll figure it out when you guys are doing the next one. So now we do the same thing with the blue. Don't need to rewrite the formula because I have it there. Oh, actually, that was blue. Oh, tell you what, let's fix it like this. So we're gonna make that red, then we'll make this one blue. So this is now gonna be the blue one. All right, so I label them. I'm just gonna label them down there. X1, Y1, X2, Y2. I have the formula already, don't need to rewrite it. So my Y2 is 3. Subtract is part of the formula. My Y1 is 4. My X2 is 2. Subtract. My X1 is 5. So again, I'm going to do it over here. I get -1 over -3, which is the same thing as positive 1/3. Hopefully you were able to get through all of that. If not, it's recorded now. You're about to practice it anyway. So what was my answer then? Are they parallel, perpendicular, or neither? I remember where I'm at. Z, what are they? Parallel, perpendicular, or neither? No. Yes, again. Not done. Yes, same, right? Again, you didn't know once you've done the work's the hard part. Doing that last part should not be difficult. That's the part you just memorize. No, you don't. I mean, I'd love for you to understand why that's true, but if you just memorize it, that's fine. That's all you need for this particular quiz. If it is the same, and you do need to simplify it, because you could have gotten 3/9 once you did the math. Well, 3/9 is 1/3. So you need to simplify it. I'll figure out how to do that on your calculator because it will do that part for you. But that is the same slope. That means they are parallel. Anybody's waiting.
I was with that one.
Oh, were you? Okay. Go ahead. I thought somebody asked, but I thought you already. So you're after whenever she gets back. So try to do the check. Check problem is the exact same thing. Oh, well, yeah, it's the exact same. The next problem really is the same too. It's just that in the next one they had already graphed the line point. So they gave you lines with points on them instead of just giving you the points. So you can do the check or example 2 also. So do example 2. Same thing we did. You just find the points for the line. So line AB is made up of points A and B. So if I kind of skipped over that, but yeah. The name of the line comes from the 2 points you're gonna use to find the slope. So line AB is why I used A and B. Line CD is why I used C and D. That one. So it's page 180, I'm sorry, 191 on training. We're still looking. So again, this is the easy part. Don't sit there and do nothing during the easy part. That's the part you gotta have that. Some of you, when we get to the hard part, it's gonna be tough. It's tough for anybody, but some of you will pick it up. Some of you may struggle to pick it up. Let me change attendance real quick since. Andres, you didn't come back from testing. You just came. Oh, I'm tired. How do I change this? Present. No phones out. Be working. Again, you don't get tons of practice time. It's been nice. Push the calendar back some, but we had a little bit. Anyway. So here's what I want to do. Should already have been done on that one. Go back and do it on that one first. Either you can label it right, if you think you can write small enough, you can label it just like I did right in the, like I did down here for C and D. I just labeled X1, Y1 right next to the numbers, X2, Y2. Or if you want to make more room, you have plenty of room on the side, do it like I did for the A and the B, where I rewrote the points and then the next one. And then when you come back, this is the formula. So for the red, I just plugged the red numbers into that formula. For the blue, I just plugged these blue numbers, which came from the blue X and Y's. I just plugged those numbers into that same formula there. Copy that down first. So again, when I come over and there's not even anything copied down, that's a great conversation with parents, because there's not much they can say to me. I walked over and they didn't even copy down the problem that I worked out right in front of them. And I'm working my way to fifth period. You guys are next. Third period is pretty much done. Well, actually, that's not true. I got a bunch of people about halfway through. And fourth period is not too bad, so there won't be many in that class. Fifth period's coming up. Did send a message already to every parent. If you're done, raise your hand. I'll come over and look at it real quick. I don't remember the answer, but if I look at it, I can probably. Yeah, or if you just want me to check. I feel like those, I'll know more when you finish. Yeah, when you finish that, go ahead and draw the lines, please. Yeah, you just connect up. Oh, you draw a line. So I'm gonna go get you like an index card. No, you're on? All right. And yeah, just as straight as you possibly can. Just be careful. If it's sometimes a good idea. If you're not going to use an index card, just do it really light. like just really lightly, and that way if it doesn't look good, you can do it over. Don't darken it in the first time. So draw it really lightly through the points that you have on the graph. And then if you feel like, yeah, that looks good, I like the way that looks, then darken that line. And that'll keep you from having a line that's way off and doesn't look good. Yeah. So I'll give you another, I want you, if you get done with the check for example one, go ahead and go to example two. It's the same thing. It's just they kind of already given you the lines instead of us graphing the lines. Don't read the solution though. Remember, when it starts saying step one, they are doing the problem for you. That you would not have that. You need to figure out how to do that part on your own. So cover it up, whatever you got to do. Only thing you would have really are the 4 points. Line graph. You don't connect. It's not a shape. It's two lines. The lines. The line of points A and B would have actually connected O and B. That's a line. I better show that. So just really quickly, and I'm not putting the points exactly where they are. Maybe I will. When you're creating the lines, so I guess the lines are not on. Oh yeah, that's the check problem, right, David? That's the check problem. Like, here, hold on, I'll show you what I mean. It's that problem right there that we're doing. So when you're putting the lines, and let's say I'm just going to kind of eyeball it, I'm not even count. So point A is like way over here. Point B is negative 11, 0. That's point A and B. Now connect them with a line. Like don't put all 4 points on there. It's two separate lines. It's not a shape. Sometimes we do get 4 points that make up a shape. Now I just draw a line through those 2 points. And then I now come back and do point C and D, and I draw a different line through those 2 points. Color pencil is good for this. If you want to keep the lines very separate and different colors, sometimes that helps. So now, I mean, you can probably make a guess if it was a multiple choice test, what the answer is. What do you think the answer is? So you think perpendicular, so that looks like a right angle. Perpendicular would be all right angles, right? What do you think? You still think perpendicular? So that's why, yeah, but sometimes you won't visually be able to tell. So that's why you need to do that. So now do the math, label them x1, y1, x2, y2, find the slope of so use for this line. That line, I think that's A and B. You just use A and B, and you find the slope. For the other line, which is C and D, you just use C and D and find the slope. And it's the same slope in there. If it's different slopes, that's when you have to multiply them together and see if you get -1. There is a mode, actually a couple of modes that sometimes kids actually put in. Do it again. What are you doing first? Let's make sure you're using the right points. Maybe 14, 13, -11. Okay, so you got the right points. That's when you label them correct. That's half the battle. So one thing you haven't done that I would like you to do is write the formula down. Just going from I'm just telling you, just based on experience, kids mess up when they don't have the formula right next to this. So I would have written y2 subtract y1. Actually, let's do. Always starts with this. I don't. That's not correct. I want this to be your example. This something. 15. Now, right the phone. Why choose a direct line one in my bag? Choose right.
Maybe.
Why it is, why choose to try. Well, no, that's right. That's exactly what I don't, I want you writing a formula on your paper. I'm telling you, you will mess up. I messed up earlier when I didn't. I actually used the wrong 2 points. I used point B and C instead of C and D or something. But anything can happen. Folks, so how do you test to see if it's perfect? Nope. Do that and see what you get. If you get that number, then they're perpendicular. If you don't get that number, they're not. So they would be neither if you don't get that. Oh. Let me get back again. Oh, you're just doing that? Yeah. I'm sorry. I meant to just tell you whenever she did that. And now, why, there we go. Perfect. Perfect. To -11. There we go. Now I think you're. Well, for this, you have to use the negative symbol, then you're just saying subtract 14. Negative is that guy. Maybe that's football. Maybe. Well, I think you. What? Now, just understand what is a negative divided by a negative, though. So that positive 13.20. And now do that same exact thing for them. Now you have a perfect example to work. So what's your answer? That's for perfect. Oh, you weren't looking for this. This is the test. So once you have your two, you know they're not gonna be the same slope, same parallel line, the same. So we know it's not that. To test and see if they're perpendicular. You know what this means? Half multiplication. Okay, so you would multiply this times this. This is actually positive. Actually, negative divided by negative is positive. Remember that, so I can show you. So if you multiply two slopes together and you get -1, then they're perpendicular. Always, I know. So you just, once you have the two slopes, just multiply them together. So what is that really then? Final answer. Not a decimal. Significant. Five. Not, right? That was it. So what's the last option? Ah. Huh. So actually, the calculator won't always simplify a fraction for you if you have two negatives. It won't let you put in a fraction with a negative on top and a negative on bottom. So you're gonna just have to make sure you memorize those rules. A negative divided by a negative is a positive. That's really the only way you have to do it. Because it'll work if you only put in one of these. So I'm trying to see if we can simplify it. But just remember, negative divided by negative. So the number part is right, so it's just 13. Now do it for the other one, and then your last test would be to multiply them together. See if you get -1. Because clearly they're not See if you got the line, not. Definitely. Yeah, same thing you did with A, because A and B is one line. It says line. Line CD is a different line. So if you put the points for C and D on them, you'll see them. And so what was the answer? Fantastic. Okay, so I want you to draw, although that's not what part of it is, that's not what it is. Negative 11. Here. Fix that, and then I want you to connect the lines. Did the math, and you multiply it, you don't put things. Yeah, there you go. So go ahead, do it just like this. This is the very next one. So the example 2, by the way, is on the very next page. So if you are done with a check problem, it's the same. No, you don't, that would not be there. I don't even know if this is part of the solution. I don't think that's part of the solution. I think they actually meant to give you the lines. It's the same problem you just did. Just do it again. The only difference is they don't tell you what the points are, right? If they don't tell you, they just show you. So you could say the points for this line are those 2 points. Points for this line. Oh, there's the other one. That points for the other line is that's what needs to be. And then I don't know if there's a check problem or not on that. I'm gonna, in a second, I'm gonna do this check problem. I think some people are done with it now. So what would your final test be? That's the 2 slopes. So what's the final test to see if they're perpendicular? Nope. Box around something for a reason. That we do when we get, we went to the 2 slopes. You know, write this next to that box. I'm gonna go because I'm kind of at the point where I'm doing this for a lot of people right now. Get all that copy down. Again, this is the slope. Where's the other one that you get it? So that's the slope. If it's the same, again, you got to know how to come up with that. But I want you to try. Looks like you. Is this for this problem? Yeah, that's right. So this is yeah, you got it set up right. You just did it. Dude, use a calculator. You got it all. That's correct. If you set it up right, you just use a calculator. So say 0 subtract. Well, you got the negative. That's correct. That's right. Oh, this is right. Now say negative 11 subtract 14. Oh, negative is down there. So you have negative 13 over negative 25. That would, what you had set up was right. You just didn't do the calculator. So erase the I don't know and then the 14. Like negative 25. So hold on a second. I'll do it in a minute. Keep working. Like I said, go on to the next page in example 2 if you're done with the check problem. So this is the part I said you have to memorize. I was hoping the calculator would fix it for you, but it doesn't. A negative. So you need to write this somewhere. It'll come up a lot. A negative divided by no, don't erase it. A negative. What I'm about to say. You're gonna. A negative divided by a negative or a negative times a negative, same rule, is a positive. So this is actually positive 13 like this. So just say equals, actually come to the side so you can see both numbers, equals 13 over 25. So I want you to write like the word slope right there and just put an arrow that points. That's what you just figured out. You just figured the slope of this line, AB. Now though, we got another line. I think you may have put the points in the wrong spots. So let's go over that. Negative 3,7 is where negative 3,7 is. Well, there they're positive. So negative 3 is in between the negative 2 and negative 4, and then go up to 7. Put a point there, and that's perfect, just somewhere in the middle of, yeah, there you go, there's 1. So now show me where, say, negative 4, negative 5 is. Right? There, put a point there. So that point right there is your other line now connect those points. So immediately by graphing it, what would like what did we just eliminate? Which option is definitely wrong? Yeah, they're parallel, they don't intersect, which clearly, so that's done. We know it's not that. So now we just do the math to find the slope, just like you did. What we use, and you got them labeled X1. Yeah. Well, what did you label these? It looks like you wrote Y1, X1 or something like that. Okay, this though is your ones, right? So you can't have another one that's X1, Y1. So do X2, Y2, and then do that. And then just do what you did on it. And then you'll come up with a slope for that. And then the last part is you multiply this slope times whatever your slope is that you come out with when you do the other one. And if you get -1, then they're perpendicular. If you don't get -1, then it's neither. I'm gonna kind of start working on it, but go ahead and I want you to keep working on your own. Don't just copy what I do. I'm gonna kind of do it up here and then I'll come back to it. I don't want to say stuff out loud just yet because some people are kind of wrapping it up. Uh, Um, everybody stop real quick, no matter what you're working on, because I'm gonna tell you something again. If you get the big concepts, especially on like a CLT, PSAT, I think it's all multiple choice. EOC will have some that's not just multiple choice, but if it was, what's gotta be there? Are they parallel? The red and the blue? Okay, hopefully we know they're not parallel. They can touch. So we know they're not parallel. What would have to be true? What is the test? Some of you are there, some of you haven't gotten there yet. What's the test to see if two slopes are perpendicular? No, we do some math at the end. We have a slope and a slope. We want to know if they're perpendicular. We do what? You just say, you can just say it out loud.
Slope.
Well, what did it say? That's the one I was looking for. What did it say?
When they have the same slope.
Well, that's parallel. Perpendicular wouldn't parallel the same slope means they'll never touch. That's why they have the same slope. Perpendicular, they're gonna touch, so they can't have the same slope. If we multiply two slopes together and we get -1, they are perpendicular. Negative part of that is big. What's the only way to multiply two things together and get a negative number? It's gotta be true. We have two numbers and we want to get a negative number. What's gotta be true? We gotta have one negative and one positive, right? Because a positive times a positive is positive. A negative times a negative is positive. So we gotta have one negative, one positive. Everybody good on that? What did I just tell you about the slope visually of line? When I was in. So what's the slope of the red line, positive or negative? Yeah, it's again, it's a little tricky to tell, but I'd be walking really straight up if I went left to right. That's positive. What's the slope of the blue line? Negative or positive? It's also positive, right? Is there any way I can multiply two positive numbers together and get -1? Can't be perpendicular. There's no way, I don't care what my numbers come out to be, a positive times a positive is gonna be a positive. I could get +1 possibly, but I cannot get -1. So I know already what it is. Now I'm just gonna give you one on my quiz that makes you work through all the math. But again, on a multiple choice test, if it's truly just one of three options and that's all you gotta do is pick the right option, there's no way that can be perpendicular, even though they kind of sort of look like it. Can't multiply a positive times a positive and get a negative. I'm still gonna do it really quickly. Which one did I do in red? So we'll go to blue for A and B. X1, Y1, X2, Y2. A lot of you aren't writing the formula, and it costs some of you. So I would tell you at least once. You don't have to write it twice, as long as your numbers are pretty close to it. My Y2 is 0. Subtract. My Y1 is 13. Divided by X2 is negative 11. Subtract 14. Here's the part that only reason I'm even doing this. You have to memorize this one. I was hoping the calculator would fix it for you and it doesn't. You have to know this is a positive number. If you try to put it into the calculator with a negative over a negative using the fraction button, it gives you an error. Now you could just divide it out and get a decimal and you'll see it's positive that way, but you need to keep it as a fraction to know if you're getting like positive or if you're getting -1 when you multiply. So that's that slope. I'm not going to do the other one all the way out, but when you multiplied it out, I think you got -12 over -1. So again, that is positive. That's the red line. Oh, and it's very steep, right? So that makes sense that it would be a really high number. This one's flatter, less than 1. Like it's lower than what a slope of 1 would look like. So again, it makes sense that we got a fraction out of it, something less than 1. So if you get those concepts down, this might save you time. It'll certainly save you from making mistakes. All that stuff will be helpful. And then when you go through the math, if you do make a mistake, I'm not going to do anything with example 2. It's the exact same thing we just did. The only difference is I think it's hard to tell because the graph and the lines might be part of the solution. I don't know. But the only difference is they gave you lines already on the graph, I think, and you have to pull the points from the lines. In this problem, they gave you the points for line AB and line CD. In example 2, you just have to pull the 2 points off of line AB and then pull the 2 points off of line CD that you would use to do all of this. Did anybody do that one? Example 2? What did you get? I don't know what it is, so I don't have the. So again, I'll share answers with you at some point, but again, a lot of you shut down after you do one problem. I think it's clear that that's not enough. I told you, you have to go way past that point where you think you got it to make sure you got it. You know you're going to lose some of it. You're going to sleep. By the time this quiz happens, it won't happen until next week. You're going to forget a lot of what you did today. You don't practice it a lot, way beyond just what we did today. All right. Oh, if you didn't write this down, the IXLs are not a perfect match for this lesson. I'm not going to pull the questions straight from the IXLs. They do have some questions in here, though, that are the same. So this first IXL, ZK2, it's got some problems in here just like example 1. But I did the IXL all the way to 100 last night, and I only got 2 questions like this example. So most of them were super easy. It was questions like this. If I want a slope that is the perpendicular slope, so one line has a slope of 2/5. What is the slope of the line perpendicular to that? That's the question. So think about it. So one slope, one line, line R, gave you a name of a line. Line R has a slope of 2/5. And then it said line S is perpendicular to line R. What is the slope? I want you to think about that. You should all be able to answer that. You can't? Now's your chance. You're going to see the problems in the book. I'll show you one of them. I think they're in your problems. I'm going to call. It's one. Andre, you came in late, so let me see if you got this part out of it. Yeah, you kind of did it, but not exactly the way I did it. What would the the line perpendicular, whatever line this comes from, that's the slope of the line. Line S or whatever it was. The line that is perpendicular to that would have a slope of what? So this is positive, so we know it's got to be negative. We've already always got to have one positive and one negative slope. Can't be negative and negative, can't be positive and positive. So then we just flip the fraction. That's how you make a perpendicular slope. All you do. And then if they said, what's the slope of the line parallel to that? What would it be? Go ahead. Put the line parallel to that slope. I'm talking about the two. What would the line parallel to this line be as far as slope? Oh, same slope. Remember, parallel lines, and so it'd be the same number. And they're that easy in the IXL. That's why that IXL may not be super helpful. They literally say, what's the slope of the line? It is like they repeat that over and over again. Like once you do it 2 or 3 times, you know it, but then they just repeat like as the levels get more difficult, the questions don't change. There's 4 levels, but the level 4 questions are the same as the level 1 question. It's ridiculous. I don't know what I think it was a mistake, frankly. So yeah, same slope for the line that's parallel. It's called the opposite reciprocal for the line that is perpendicular. So when you do that IXL, just know that's not going to be on the quiz. You need to know that for other stuff we're going to do, so it's still helpful. This is what's on the quiz. This kind of problem. Right? All right, so the only other thing I'm going to do, and I'm going to do it really fast because I didn't get through much of it in the other class. Look at example. We didn't get into writing equations. Example 4, but where is it at? Oh, there it is. So example 4. I don't know the page number, but just keep going forward until you get to example 4. This is a very visual thing. So again, as long as you remember what I just told you about perpendicular slopes, this one's really not too bad. So now we're kind of at like the middle level. We did the easy stuff. That was just determining if it's parallel, perpendicular, or neither. This is the middle level of difficulty. I don't think I can zoom in anymore. Oh, yeah, I can. All right. So they give us this real life example and graph and blah, blah, blah. Again, none of this would be there. You wouldn't have any of that. That's them solving it. All you would get is that graph, that picture. It's really not a graph, theoretically. And that bold question or problem, whatever. All you're doing is you're creating a line that's perpendicular to this line. That's what it boils down to. They give you this whole thing about a fountain through this blah, blah, blah. I want you to read through it and try to understand it because a lot of the EOC is reading comprehension, but it boils down to creating, and they down in the solution, they draw an actual graph. This is the line though, going through those 2 points. They want a line perpendicular to that goes through that point. Here's my first question. What do we need to know? What do we say when we're talking about parallel, perpendiculars? What do we need to know? Slope. It's always going to be slope. Parallel, slope. Perpendicular, slope. In this lesson especially, but even really in the future. So I need to find the slope. So I want you to do that. Find the slope of that red line. You can look at the numbers in your book. Label just like what you just did. Label x1, y1, x2, y2. Write the formula down. And then next to that, plug in the numbers in the formula. That part's the easy part. Tricky part is knowing how in the world do I create the perpendicular line, but it's actually not that.
But you tell what, like, -6, -2, 0, 1.
Yeah, those are the points on the line. It's in your book. It's on, I don't know what page, but just keep going forward. It's example 4. That exact 195 or when I, because it's a little tricky to see it up here. I know I can't zoom in anymore. Whenever I copy stuff straight from the book and put it in there, it's I can only zoom out so much. Give you another minute. Hopefully, I guess I can go ahead and kind of start solving it. Now my board's working fine. I don't know why I'm messing with it. It's weird. All right, so hopefully you've gotten to this point at least, if not farther. This is if you're struggling still, some of you are a little bit. I would set it up exactly like, I mean, that's your template. Write the points up here, leave a little space. I want it all pretty close together, but I want a little space because I'm going to write the numbers right above the Y's and the X's or below, depending on which one I'm doing. So I'm going to say, well, my Y2 number is -6. So I'm going to write -6 right above Y2. Subtraction is part of the formula. I can't get rid of that. That needs to be there. My Y1 number is negative. Do not lose the negative. Like I said, everywhere that 2 goes, that negative goes. They're glued together. The sign in front of a number is glued to it. It's like that -6, that negative is there. -2, that negative is there. Now I do the same thing on the bottom. You can do the math on that. That would be -6 plus 2. You have a calculator, so I'm just going to show you it's -4. X2 is 0. Subtraction is part of the formula. Oh, I pointed the wrong -6 over. There's 2 of them. -6 is the X1. So I have to keep that negative with that 6. Can't lose it. It's part of that number. Well, if you do the math on that, +6. Now, I think your calculator does actually try this real quick. Good enough. Put that in like this. Everybody, if you have a blue one, it won't work on the, actually the white one says this too. Put in -4, so use the negative button down where the equal sign is, and then 4. Then hit the ABC button. It's kind of in the upper left area. Hit that button, then hit +6. And hit equals. Yeah, it converts, simplifies it for you. It says -2/3 on the count. So it will as long as it's not a negative over a negative, it'll simplify it for you. So that is -2/3. Now, though, I want a perpendicular line. Here's the little bit tricky. How do we create the slope of the line perpendicular? That's why we create a perpendicular slope. What do we say? So we change the sign, we flip it, we don't make it negative because it's already negative, so it's going to be positive, which means I don't need any sign. And then I do what with the numbers? I flip them, right? So the 3 goes to the top. So that is my perpendicular slope. Now, when we get to writing equations, it gets much more difficult, but if you're just graphing the line, now I just graph the line using that slope. That's my rise and my run. So I go over 2, up 3. So right there, over 2, up 3. I kind of need to go toward this line though. I mean, I could connect that and draw it. Just reverse both directions. Instead of going right 2 and up 3, go left 2 and down 3. Left 2 and down 3. Now you've gone to the other side of that and you just kind of, I don't think they say anything about creating an equation. You just physically need to draw the line, and that is all you have to do. So again, we created the perpendicular slope. That was, well, I mean, all of this was step 1, really find the original slope. Created the perpendicular slope. Then they didn't want an equation. They just wanted us to graph it. So we just graph like we would anything, follow the rise and run. So it would look over 2, down 3 would be there. So about like that. So we will get into stuff more difficult than that. Today, like I said, we just do the easy level and then the medium level. Difficult level will come up on another day, probably not Friday, well, definitely not Friday, because we're doing the district test. Bring your laptop. District test in class, we're not going to lab, so you need your laptop. Really, see third period tomorrow, I gotta send a message home to at least first period. I'll probably just send it to everybody, so. First period's pretty good about bringing it in. You guys been practicing outside at all for wrestling? Have you? Yes. What time do you know, like, are you normally in that spot that I saw you?
Basketball, oh my God.
You went out there with them?
I see.
That's awesome. Oh, wait, you saw them or you
Yeah,
did it with them?
I was watching track and like I seen them working out by like.
Oh, yeah? I'm gonna suggest though to Coach Jacobs that you guys do that with them.
Miserable.
I think that's a great idea.
But oh yeah, they just gave me an idea, so that's fine.
Yeah, dude, Coach Washington will be all about getting basketball.
We had to do stadiums.
Cause he's only got a couple girls wrestling. He'd love to have more girls.
We only have one, but she hasn't been coming.
I saw two the first time. Maybe she wasn't wrestling.
Well, no, one of them, there was two. One was wrestling, the other one is
That is a great idea.
But
I
the one
can't wait to
is-
see Coach.
she's
Let's
not.
get that. You know.
The. It's
Or-
giant.
or- You should see it, you should see it when they had to drop weight for their competition. Where they wear like garbage bags and wrap all up and plastic.
Yeah, I
and
wear-
stuff,
I
and they
wear-
can run. To lose water weight, which is really not healthy, but. I used to have buddies that wrestled. And buddies that did like bodybuilding, they had to do that same stuff.
I wear.
In boxing, like, yeah, so. Yeah, I haven't seen you guys when I left since then, really, just that one day. Pretty much always parked.
That day was like.
At least it's getting cooler. I mean, that's a good sign. That's the upside of things.
We had to do-
Oh, I gotta stop the recording.
We had to do lunges like. We had to do lunges all the way down.
I
And
thought
jump
that's what I
squats.
wanted to do. It's like,
Do you have like long hair?
it's kind of like Mexico.
Rocky.
Yeah. You start going.
But you didn't give up. That's good.